Hey guys, welcome back to my channel and I hope you are all doing great. Today we are going to solve one more Leetcode problem. The problem difficulty is easy. Problem number 35, search inside position. Let's see what this problem is all about. We are given a sorted array of distinct integers and a target value. We need to return the index if the target is found. If not, we need to return the index where it would be if it were inserted in order. Okay. We must write an algorithm with big O of log and runtime complexity. Let's understand this problem in a diagram for a better understanding. Assume we have an input set like this 1, 3, 5, 7 and our target is 5. If we carefully observe, target is present in our input array and we all know in array the index starts from 0 and this is going to be 1, this is going to be 2, this is going to be 3. So what we need to return? We need to return index of the target, okay, at which position it present. So that is nothing but 2. Here the output is going to be 2. Okay, let's see another case. 1, 3, 5, 7, 9 and target is what? 6. If we carefully observe here, 6 is not present in our input set. First let me tag the indexes. Okay, if we carefully observe at which position 6 can be inserted, 6 can be inserted at third position, right? Here 6 can be inserted and 7 will going to be at fourth index and 9 will going to be at fifth index, right? In this case we need to return 3 because in this sorted array 6 can be inserted at third index. Okay, this is all about the problem statement and I hope you got this one. Let's see few cases on the problem. If we carefully observe, in problem they are saying sorted array of distinct integers. So you can think of binary search when you hear this sentence like sorted array. Okay, because binary search is going to be best fit to perform any operation on a sorted array. Okay, let's see what is other catch for us. We need to perform an search operation on top of the sorted array, right? We need to look for a target. So searching on top of sorted array is binary search, right? So we have linear search also, but linear search is going to take big of n time complexity, and we can see here one more constant from problem. We need to achieve this in big of log n time complexity. So binary search time complexity is big of log n. So looking at the problem statement, we can clearly see this problem can be solved using binary search. Okay, let's see how we can solve this using binary search. I'm going to take the same input 1, 3, 5, 7 and first I'm going with the positive case, okay, where target is 5. As you all know, in binary search there are total 3 keywords, okay, which are very important to solve the algorithm. One is low and other one is high and third one is mid. Low always points to the 0th index, okay, it will start from here, and high always points to the last index, that is nothing but 3. Mid is going to be low plus high minus low divided by 2. This is the formula to find our mid element. Okay, let's see here. 0 plus 3 minus 0 divided by 2. Okay, what is going to return? 0 plus this complete thing is going to return me 1. So then our mid is going to be 1. So initially if we take this input 1, 3, 5, 7, okay, my low is going to be at here, my mid is going to be at here, my height is going to be at here. Okay, now let's perform actual binary search. Okay, 1, 3, 5, 7 and as I said, this is low, this is mid, this is high. What is the first condition? Is mid, that is nothing but 3, equal to 5, not. Then what is second condition? Is mid less than 5? Here 5 is nothing but target. Okay, instead of 5 it is going to be target. Okay, target is also nothing but 5. That's the reason I'm directly taking 5 here. So is 3 less than 5? Yes, condition satisfied. So when our mid is less than our target, the immediate action is going to be low equal to mid plus 1. Okay, low should point at mid plus 1 position. Okay, after this one, how my pointers is going to look like? 1, 3, 5, 7, and my mid is going to be at here only, but my low will come to here. Okay, my high is going to be here. I'm done with first iteration. Okay, now let's see. My mid is at first position, low is at second position, high is at third position. Again I need to find the mid. So from low plus high minus low by 2, from this formula I can get mid as 2 this time, because my low is at 2 plus my high is at 3 minus 2 by 2, 2 plus 0, nothing but 2. Okay, so after finding mid, so how my pointers going to be? 1, 3, 5, 7. Already my low is here. Now my mid is also going to be at here, and my high is here. So now the second, now the conditions again. Is 5 equal to 5? Okay, this 5 represents mid. Okay, mid index value. Okay, yes, right. In this case, simply return mid. Simply return mid, because we found our target in our input set, right? So just simply return mid. So this is all about the positive case. What I mean by positive case? I mean by the target which exists in our input set. Now let's see a negative case, like where our target is not going to be part of our input. Okay. Now let's take input set 1, 3, 5, 7, same set. Okay. This time my target is going to be 6. Okay, now let's apply the same routine. Okay, where low is equals to 0, high is equals to 3, initially mid is going to be quite 1. So is 3, 1 is nothing but this, right? Is 3 equal to 6? No. Is 3 less than 6? Yes. So what we are going to do? We are going to increment the low, right? Then how my pointers going to look like? My mid is going to be here only, but my low will come here, and my high is going to be here. Okay, now let's see. My mid is going to be 2 according to the formula. Okay, this time. So how my pointers going to be? 1, 3, 5, 7. Okay, my low is already at 5. Now my mid also joins with the low, and my high is at here. Is 5 equal to 6? No. Is 5 less than 6? Yes. In this case, what you need to do? As usual, low is equals to mid plus 1. Let me do the same thing in next screen. 1, 3, 5, 7. Now my low is going to be at here, my high is going to be at here, and my mid is already at here. Now let's apply the same formula. Okay, that is nothing but mid is equals to low plus high minus low divided by 2. From this formula you're going to get mid as 3. Okay, by substituting values of low and high. So my mid is going to be at this position. Okay, 1, 3, 5, 7, and mid, low, high, all are at same place. Okay, pointing to same element. Now let's come to the same thing. Is 7 equal to 6? No. Is 7 less than 6? No. Then what is the next condition is going to be? Is 7 greater than 6? Yes. So here greater condition is satisfied. Till now only less than condition satisfied. Now greater condition satisfied. So as soon as this greater condition satisfies, what we need to do? It is we need to do high is equals to mid minus 1. Okay, then what my high is going to be? My high is going to be at this position. Okay, now finally we can see how our values are like this: 1, 3, 5, 7. My high is at this position, and my mid also here, and then my low also here. And here you can see your high is less than low, right? So this is a termination condition for our loop. So we come out of our loop. Okay, our loop starts with this condition while low less than or equal to high. Till this condition only we are going to perform this all operations like finding the mid and checking the mid value and incrementing the low or else decrementing the high. We all do these operations until this condition satisfies. Okay, as soon as this condition not satisfies, so you come out of that loop. Okay, once you come out of that loop, okay, you return the low. Okay, just return the low. Why you need to return the low? If we carefully observe, our target is 6 and we saw 6 can be inserted at position 3, right? So if you carefully observe, where is my low? My low standing at index position 3, and that's a position for our 6, right? So that's a reason you need to return your low. Okay, if target found, you need to return mid. If target is not found, you need to return low. That's all. Okay, I hope you got the solution also. Let's solve this problem. First is going to be into low, that is nothing but 0. Then next is going to be into high, that is nothing but nums dot length minus 1. Okay, and as I said, this all operations going to take place inside a loop. Okay, further the exit condition is going to be, we need to iterate till low less than or equal to high only. Okay, the first step for us is like we need to find the mid. How we can find? Mid is nothing but high minus low divided by 2. Okay, now if nums of mid is equal to target, just return your mid because you found the target value in your input set. Otherwise, else if nums of mid is less than target, if it is less than, then what you need to do? You need to increment your low value. Okay, else you need to decrement your high value, mid minus 1. Okay, after completing this loop, if you didn't find anything, okay, just you need to return low. Low is going to point the index position where your target can be inserted. Okay, let's run it. Great. And we can see the target is 4. 4 is not present in our input set, so 4 can be inserted here at position 2. That's the reason we got output 2. Let's see a positive case also here. Let's look for the 5. 5 is already there, so we need to get 2. Sorry, I clicked on submit by mistake. Yeah, you can see this got submitted, and the runtime was 0 milliseconds, and it is faster than 100% of Java online submissions. Thanks for watching my video, and I hope you learned something new today. Please do subscribe and comment and like. Please encourage me. I'm going to share more content in future.